We are going to close off section 1.3 with some vocab. So there's this super important vocab word that you have no homework problems on for tonight. There will be plenty of future homework problems that involve this idea though, and this is where we meet it for the first time, so it's worth unpacking. So this is the definition from your book of span. So let's talk about span a little bit and see if we can unpack this definition with all its math jargon. So it says that if V1, etc., through VP are in R sub n, okay, it's already getting a little bit thick here, but let's see if we can unpack what they're talking about. So V1 all the way through VP, those are vectors. And they're in Rn, so that'll be something like R4 or R6. That tells you the dimension. For example, if we were in R4, we might have a V1 that looks like 1, 2, 3, 6. And we might have a V2 that looks like negative 1, 3, 2, 4. And maybe that's all we've got. Maybe we've only got a V1 and a V2. Okay, so far we've got a V1 and a V2 that are in R4. Then the set of all linear combinations of them is denoted by span. And when they say denoted, they're just saying this is how we notate this. This is how we actually write it down. The word span, curly brackets, write the vectors inside. And is called the subset of R4, in our case, spanned or generated by the vectors. Okay, so when we write down something like span parentheses 1, 2, 3, 6 and negative 1, 3, 2, 4. That'd be the notation. And what we're talking about here is every possible combination of these two vectors. So that's infinitely many results, right? The span of these two creates infinitely many vectors. One particular element of the span would be what you would get by, here, I'm going to shorthand this. That's V1, that's V2. One element of the span would be what you get by doing 2V1 plus 3V2, which is, let's see, 2, negative 3. So it's got like negative 1. I'm not going to add it all up, but you get the idea. You would get a vector, four-dimensional vector, by doing that. That's one element of the span. So is 6V1 minus 10V2. That's also an element of the span. So is 3.17V1 minus pi times V2. Now, those are all elements of the span, so just any possible combination. And this span will often ask questions like, is something in the span? So we might say something like, is 0, 5, 5, 10 in span V1, V2. And you would know how to translate all this language, and you would just say, oh, what this person's really asking is, can I somehow combine V1, which is this vector, and V2, which is that vector, to produce this one? In this case, the answer happens to be yes. And you can prove it just by saying 1V1 plus 1V2 equals 0, 5, 5, 10. But there might be others that aren't in the span, and You could solve any of those if it's not just obvious like the one I just did. You can solve all of those by row reducing the augmented matrix. Okay, I think that's it for 1.3.